Hello guys, welcome to the channel. Today we will discuss naive Bayes algorithm. So what is naive Bayes? Naive Bayes is a classification algorithm based on probability and the Bayes theorem. We all studied Bayes theorem in probability and statistics, and it predicts the class or category of data using probabilities. Remember, using probabilities, okay? For example, spam or not spam email, positive or negative review, disease prediction, news category prediction. So this is on which naive Bayes algorithm works. Okay, this kind of examples. Okay. So what is Bayes theorem? Bayes theorem is A by B is equal to PB by A into PA upon PB, where P A by B is equal to probability of A given B, P B by A is equal to probability of B given A, and PA is your prior probability and PB is your total probability. We are all studied Bayes theorem. Okay. Now, there are three types of naive Bayes algorithm which you can use practically. First is Gaussian naive Bayes, second one is multinomial naive Bayes, third one is Bernoulli naive Bayes. So now we will see when we use three different types of naive Bayes. So when we will use Gaussian naive Bayes, when data is continuous numerical data. Continuous numerical data. Data follows normal distribution, means bell curve. Okay. For example, our features will be height, weight, right? So in this kind of things, we will have continuous numerical data. So we can perform Gaussian and beyond that. Okay. Now second one, multinomial neighbors. When we will have textual data, text data. Okay, data is discrete or count based. Okay, so it is mostly used in natural language processing. Okay, so we will cover that also. Bernoulli and Bernoulli neighbors, when we will have binary features, for example 0 1 true false yes or no, then we will use Bernoulli neighbors. So I have explained when we can use Gaussian NB, multinomial NB, and Bernoulli NB. Now, I will show you how we can perform these three on basically practically on a data set. So I have this data set on which I will perform all three types of naive Bayes algorithm. Although it will not like satisfy the condition for some algorithms. For example, Gaussian NB, it is like satisfying the need for Bernoulli NB because I have 0, 1 category here, only two categories, binary features I have. So yeah, but although my objective is to basically give you an idea how we can perform these three different type of naive Bayes algorithm practically. Okay, so now we will see how we can do it practically. Okay, first I will import my pandas libraries, pandas as pd. Now I will load my data set pd.read/csv. Now this is my data set. I will right click, copy path, control V. Now data dot head. I will check my first three rows. My data gets loaded or not. Yeah, my data gets loaded. Okay. Now, now I will separate my data into input and output column. In X, I will take all input columns, these two columns, and in Y, I will take our output column. Okay. X is equal to data. I will use ilog. I'm saying give me all rows, give me all columns, but don't give me -1 means last column. Okay, because this is my output column. I will take my output column into Y. Okay, I will copy it. Sorry. Okay, now shift plus enter. Now my data gets divided. Okay, into input and output. Now I will divide my dataset into training dataset and testing dataset. I will take 80% for the training and 20% for the testing. Okay. Now I will import train test split dot model selection import train test split. Okay. Now I will take my all four variables x train, x test, y train, and y test is equal to, I will call my train test split for which variables x and y. I have taken my input and output. I will give test size as 0.2 because I want 20% as my testing data. Now random state I will choose 42, right? Now my data gets divided into training data set and testing data set. Now I will perform all three different types of algorithms of naive Bayes one by one for this data set. Okay. Now first I will import all three algorithms of naive Bayes sklearn dot naive Bayes naive Bayes naive Bayes import first Gaussian NB. Second one is our multinomial NB. Multinomial NB. I already explained when we use Gaussian NB and multinomial NB and Bernoulli NB. Okay, but I am just showing you on this data set only by applying all these three algorithms. Okay, Bernoulli, Bernoulli NB. Okay, I think I have did some spelling mistake here. So I will just copy paste. Okay, double L. I think I missed double L. Okay, okay. So I have imported all this. Okay. Now first, suppose I will make an object to call Gaussian NB. G and B I have taken an object. Okay. Gaussian tab. Now we can call it. Okay. Now I will fit my X train and Y train into Gaussian NB. X train and Y train. Okay. Now it gets fitted for my Gaussian NB. Okay. Now I will show you suppose accuracy of my model. Okay. For X test, Y test into 100. Suppose I will show you the accuracy of training also. Okay. I will give train. Okay. Now, so 83% accuracy we are getting for our testing and training both. Now I will use multinomial MNB is equal to, I will call my multinomial. Okay. Now I will fit my training data for multinomial here. I will just, okay. Yeah, it gets fitted. Now suppose I will check the accuracy for this MNB and MNB. So Same accuracy it is showing. Okay, for my Gaussian NB and multinomial NB. Let's check Bernoulli NB. BNB. Bernoulli. Okay. Now, suppose I will fit my training data for Bernoulli. Now, BNB. Okay. Sorry. BNB. Okay. Yeah. It gets fitted. Now, suppose I will check my accuracy for Bernoulli. Yeah. It is giving accuracy for all these three algorithms of naive Bayes. Okay. So we saw in this video how we can use different types, three different types of naive Bayes algorithm. When we use these three different types of algorithm, in which cases I explained already. Then we checked how to use these three different types of algorithm, Gaussian NB, multinomial NB, Bernoulli NB on a data set. Okay, so that's all in this video. In the next video, we will start our non-linear supervised learning algorithms. Okay, so that's all. Thank you.